All right, I am recording. All right, the very first thing we have to understand when we do Pythagorean theorem is we have to understand that, what it means to be a right triangle. Okay, so a right triangle has exactly one right angle. So let's go ahead and label that on your right-hand side. And you'll notice that how do they show a right angle in a right triangle? Got a little box in that one corner that is exactly 90 degrees. So go ahead and label that. Now, this is where we could start putting names to parts of this right triangle that helps us understand the Pythagorean theorem. Once you have established or found that right angle, the side that is exactly opposite of that, right here, is your hypotenuse. Not hippopotamus, hypotenuse. Okay, label it. This is how you know it's a hypotenuse. A hypotenuse is the side opposite the right angle. It is always the longest side. In the Pythagorean theorem, this is the Pythagorean theorem right here. A squared plus b squared equals c squared. The hypotenuse is c. The hypotenuse is c. So the hypotenuse is diagonal from the right angle, 90 degrees. It's the opposite side of the right angle. It's always the longest side. And it stands for the c in Pythagorean theorem. Okay, so that leaves two other sides that we haven't talked about yet. This side and this side, the ones that are touching the right angle, are what we call the legs of a right triangle. These legs are going to be shorter than the hypotenuse, and we give them the names A and B. They are the legs. Okay, let me show you why the Pythagorean theorem works. Okay, so there's this guy, and he decided that he was bored one day and wanted to mess around with some right triangles. So what he found is if no matter what size right triangle he made, knowing that this is the C and like we have A and B, if he measured the length of side B, let's say it was 3, and he measured the side length of A, let's say it's 5, and then if he made a square to fit each of those sides, so if I made a square to fit on this side, what kind of square would it be? It would be a 3 by 3. What would be the area of inside that square? Good, 9. Okay. And then he did the same thing for the A leg. He made a square that would like fit along its length. So if it's 5, it'd be a 5 by 5, which would make the area of that square what? 25. Good. So then what he did is like he cut up the square, the 9 square, and he cut up the 25 square into little units. So he had 25 little units, and he had 9 little units. And then guess what he found out? If you put all of those little units together, it fit exactly on this side. Okay, so what ended up happening is this square becomes, it was all 34 of those little squares. Right? Isn't that weird? It happens with any right triangle. It doesn't matter if its legs are 10 by 12. I could make a square to fit this side, which would be 144, and I could make a square to fit this side, which would be 100. Guess what would happen as soon as I took both of those squares, combined them? What's this side going to be? 244. Isn't that weird? So guess what? Could I find, so Pythagoras asked himself, can I find what the length of my hypotenuse is then? Sure we can, because what do we do with 244 to find the length of one side? Nope, don't divide. Square root. Right? We did this. You want to find the length of one side with the square that's in the middle. You have to take the square root of 244. So the length of that hypotenuse is going to be the square root of 244. It's 15.6204, and we know that 244 is a not perfect square, so it's going to be an irrational number. So we know the side length of the C. Do we know the side length of the C on the top one? Yeah, you take the square root of 34. Okay, sit down. No, we are not leaving yet. Sit down. How do we find the side length of C on the top one? The square root of 34 will give me the side length of C. Okay, so tomorrow we're going to do this like little packet with all these little squares that we could put on the sides of a right triangle to find these missing angles. Okay, before you can go, you have to have all of this in there. You have to have a squared plus b squared equals c squared, and you have to have this picture right here to show that this triangle, here's your right triangle, your legs are A and B with C being the hypotenuse across from the right angle, and that the square here, A squared, and the square here, B squared, will be the square on the C length.
So are you telling me that this guy just got